Greetings, welcome to this new video about nodal analysis or node voltage method. In this video, I will demonstrate how effectively solve a problem using the nodal analysis method, and I will guide you through the step-by-step process, ensuring a clear understanding of each stage. Let's consider this network consisting of 6 resistors labeled R1 through R6 as well as 2 independent current sources IA and IB. The question now is to calculate the voltage VO across the resistor R6 using the nodal analysis. Let's move on to the solution. Let's start first by labeling all the nodes in the circuits, and I will consider this node as node 1, this node as node 2, this node as node 3, and this node as node 4. After, we'll assign the voltages V1, V2, V3, and V4 respectively to those 4 nodes. Next, we need to select a reference node in the network. The reference node is typically chosen as the node with the most connections, or as the ground node. Now let's assign arbitrarily the currents in each branch, and I will consider I1 is the current in branch through the resistor R1, I2 is the current through the resistor R2, I3 is the current through the resistor R3, and I4 is the current through the resistor R4, and I5 is the current through the resistor R5, and I6 is the current through the resistor R6. Next, we'll proceed to apply Kirchhoff's current law in each node. Let's start first with node 1. By applying Kirchhoff's current law at node 1, we can write I6 is equal to IA plus I1. Now, by applying KCL at node 2, we can write I2 is equal to IA plus I3. And for node 3, we have I4 is equal to I3 plus IB. And for node 4, we have I6 is equal to I5 plus IB. According to Ohm's law, the current can be expressed as the voltage difference across a resistor divided by the resistance. This implies that the current can be determined by the following equations. I1 is equal to 0 minus V1 over R1, and I2 is equal to 0 minus V2 over R2, and I3 is equal to V2 minus V3 over R3, and I4 is equal to V3 minus 0 over R4, and I5 is equal to V4 minus 0 over R5, and the last one is I6 is equal to V1 minus V4 over R6. Now, by substituting A and F in 1, we can write V1 minus V4 over R6 is equal to IA minus V1 over R1. And if we replace the resistors R1 and R6 and the current IA with their numerical values, we obtain this expression. If we continue simplifying this equation, we obtain finally 9V1 minus V4 minus 32 is equal to 0. And now by substituting B and C in 2, we can write negative V2 over R2 is equal to 4 plus V2 minus V3 over R3. By replacing the resistors with their numerical value, we obtain this equation. And if we continue simplifying this equation, we obtain negative 3V2 plus V3 minus 16 is equal to 0. And now by substituting equation D and C in equation 3, we obtain V3 over R4 is equal to 2 plus V2 minus V3 over R3. And if we continue simplifying this equation, we obtain finally negative 3V2 plus 7V3 minus 24 is equal to 0. Let's move on now. By substituting equation E and F in 4, we can write V1 minus V4 over R6 is equal to 2 plus V4 over R5. If we replace the resistors with their numerical values and we continue simplifying this equation, we obtain 9V4 minus V1 plus 16 is equal to 0. After we finish applying the nodal analysis method, we obtain or we derive 4 equations with 4 unknowns. Let's start first by performing A plus 9 times equation D. We derive one equation is in terms of V4. That means V4 is equal to negative 112 over 80 is equal to negative 1.4 volt. And from equation A, we can write V1 is equal to V4 plus 32 over 9. And if we replace V4 with its numerical value, we obtain V1 is equal to 3.4 volt. And now by performing C minus B, we derive one equation in terms of V3. Finally, V3 is equal to 8 over 6 is equal to 1.33 volt. And from equation B, we can write V2 is equal to V3 minus 16 over 3. And if we replace V3 with its numerical value, we obtain V2 is equal to negative 4.89 volt. And from here, we know that VO is equal to V1 minus V4. And if we replace V1 and V4 with their numerical values, we obtain VO is equal to 4.8 volt. After completing the calculations, we conduct a simulation using SPICE to verify our results. Now let's proceed to the SPICE environment. Here is our network drawn in SPICE simulator. We can see here this is the independent current source IA, the independent current source IB, resistor R1, R2, R3, R4, R5, and R6. We can see here I connect a voltmeter in order to measure the node voltage V1, voltmeter V2 in order to measure the node voltage V2, V3 in order to measure the node voltage V3, and V4 is in order to measure the node voltage V4. And here I connect the voltmeter VO to measure the voltage across the resistor R6. Let's move on now to analysis. This say analysis, calculate nodal voltage. We can see here V1 is equal to 3.4 volt, V2 is equal to negative 4.89 volt, and V3 is equal to 1.33 volt, V4 is equal to negative 1.4 volt, and VO is equal to 4.8 volt. On completing the circuit simulation, we can clearly observe the similarity between the simulation and calculation results. This serves as a validation or verification of our work. Alright, thank you for watching this video. If you have any question, do not hesitate to contact me by email or leave a comment under this video and I will answer you as soon as possible. If you like this video, don't forget to subscribe and share. See you next time in another video about nodal analysis. Take care and bye-bye.